So let's do an example of calculating stress and take it to the next level to use that value to determine the safety. So our example is the tensile force in a copper wire is 4,448.979 newtons, and the cross-sectional area of the wire is 0.00127 meters squared. Calculate the tensile stress on the wire. So we have a formula for stress. We know that it's the force per surface area. And if it's a tensile, we can use the subscript T. So tensile, remember, is the pulling stress. So our formula is that sigma subscript T for tensile stress is the force over area, where the force is given in newtons and the area is given in meters squared. So we don't have to do any conversions. We have the correct units associated with it. So all we really have to do is plug into our formula. So we have our force, 4,448.979, and that's divided by the area, a surface area of the wire, which is 0.00127 meters squared. So when I plug that into my calculator and I do my division, I end up getting 3,503,133.071. So remember that this is stress. So we have a unit of force divided by area. So remember that was newtons per meter squared. But instead of using this unit, we often remember this is the same thing as pascals. And this is a really big number. So I'm going to do a conversion to megapascals. So remember that in every 1 megapascal, there is 1,000,000 pascals. So I can divide this by 1,000,000. So we end up getting approximately from the 3.50 to 2 decimal places megapascals. So that's the stress on the wire associated with this particular force is happening there. So this is the stress on the wire. So based on that, we can actually make some judgment calls. So we can determine if the wire is actually strong enough by comparing it to known stress levels for the particular material that we're using. And this is helpful to make decisions about safety. So can it actually withstand that amount of stress? Or do we need to use a different product, different material, or do we need extra supports associated with it? So below are some common materials and their approximate tensile strength, as well as their compressive strength. So these ones are the maximum that it can handle before it breaks. So again, there's different ones that you can look up comparing different products that you're actually using. So this is our tensile strength in megapascals and our compressive strength in megapascals. So as long as our unit is the same, we can do the comparator. So in our case, we were using copper wire. So we would compare the tensile strength to 220. So we're fine here in this case. So this is less than 220 megapascals. Therefore, it is safe. Just a note, though, that these are actually before it breaks units. So it might be useful to think about that though the values are at that breaking point, there are some times when you get bending and breakage and severely deforming, which jeopardize their integrity as well. So again, that's something you might learn in other capacities, but it's important to know where the mathematics is coming into play so that you can know whether it's safe to use that product or whether you need to use a different method when you're actually doing your constructions.